Okay, before we start the homework on section 4.1, I just want to go over a few notes, a few review of the things we talked about in class today. Hopefully you took these things down, but just to remember. First of all, we talk about radian measure. Now, we know degrees. There's 360 degrees in a circle. We've learned that before. That's our standard that we've always used. There's 90 degrees in a fourth of a circle or a corner. So we know what a 90-degree angle is. But now we talk about radians. This is a new thing. And a radian measure comes in very handy in higher mathematics, because sometimes we use bigger angles than just degrees. So we have a new measurement called a radian. And basically what a radian is, it's an angle that if we have a circle and we have an arc that's intercepted by an angle that's equal in length, the arc length. The length of this arc is the same as the radius. The length of this arc is the same as the length of this radius. And this angle that intercepts this arc has a measure of 1 radian. Okay, this angle has a measure of 1 radian. Okay, now we'll talk about why it's this many degrees in just a moment. So if we think about this, then this is going to be 1 radian. Now, how many r's are there all the way around a circle? Well, we know the circumference is equal to 2 pi r, right? 2 times the diameter. Diameter is 2r, so pi times the diameter. Pi times the diameter, or pi times 2r, is all the way around the circle. So if we divide that circumference by r, we get 2 pi. So there are 2 pi r's in a circle's circumference. Now, pi is about 3.14. So 2 times 3.14 is 6.28. So that means there's a little bit more than 6 r's in this circumference. And each of those r's, that angle that measures that, would be a radian. So all the way around here, we know that they're all the way around. This is 360 degrees, and that would equal 2 pi r radians. If we want to find out how many degrees there are in pi radians, then we could just divide by r, and we get 360 degrees equals 2 pi radians. That's how many r's that are in here. It tells me in 360 degrees how many radians there are. There are 2 pi radians. If I divide both sides of this by 2, I get 180 degrees equals pi radians. And then if I divide it by pi, I would get 180 degrees divided by pi equals 1 radian. And that's how I got the 57.3 degrees. I just took my calculator. Nothing fancy. Hope you can read that. And I took 180 degrees, and I divided it by pi, which is about 3.14159. And I get about 57. You can see 57.29. That's about 57.3 degrees. So that's how many degrees there are in a radian. So a radian is much bigger than a degree. It takes 57.3 degrees to make 1 radian. So that's 1 radian. So you could look at this. This is a little less than 60, so that makes sense. That means I've got 6 60s and 360. So I've got a little bit more than 6 of these, which is 2 pi, 6.28. So we know pi radians is 180 degrees. Now we can also subdivide this. If pi radians equals 180 degrees, if I divide both sides by 2, I get pi over 2 radians is 90 degrees. Pi over 4 radians is 45. Divide by 6, pi over 6 radians is 30 degrees. And divide by 3, pi over 3 radians is 60 degrees. So we can see pi over 4 is 45, pi over 6 is 30, pi over 3 is 60, and we're always just coming up from this basic idea. Now, we will also use these for conversions. We can say 180 degrees per pi radians. Okay? That means there are 180 degrees in pi radians. That would be 3 of these. Or actually 3.14 of these. That's how we're going to get the exact 180. Or pi radians is 180 degrees. So we'll use these for conversion factors. Okay? And then if we kind of sum this up, we have this very important formula up here, because if we know if we take the arc length, if we take this length r and divide it by r, we get 1 radian. All right, but if this arc length was more, if we just divide it by r, we're going to get the number of radians in that angle. So if we have a bigger angle here, we would take this arc length divided by r, and we'll get the number of degrees in radians in that angle. So we're going to be using this formula. So this is a very important formula to remember. The angle in radians equals the arc length divided by the radius. Okay, so let's try some of the homework problems, and this form is going to be very important, as well as some of these concepts. And you have to think about this because it's relatively new to you. And these are stated in the book